Hello and welcome to my session, Top 10 Observability Challenges and How Open Source Can Help. My name is Michael Hausenblas and I'm a Solution Engineering Lead in the AWS Open Source Observability Service team. So let's jump into it. Why are we doing that? Imagine yourself being a pilot. You're responsible for the lives of your passengers, and this is what you see. Essentially nothing. Compare that with this view. Which one would you prefer? I think most of you would agree that this view is the better one. Meaning that all the insights that you get here in terms of how high you fly, how fast, etc., provide you with enough information to make the right decisions. And this is really why we are doing what we're doing. Let's have a look at a more domain relevant example. Imagine you have an application. Let's say in the beginning it's a monolith. It's a shopping e-commerce application that interfaces with different outside services and APIs, third-party payment API, for example, or ERP stock app, or some SSO, single sign-on. And if we peel back and have a look at what is going on under the hood here, usually if you have done a pretty good job in terms of architecting your application, you have it in a very modular way where different parts have very clear roles. And then it's pretty straightforward to take that and turn it into a bunch of microservices. These microservices now are effectively a distributed system. So let's have a look at this microservices setup, and let's talk about the pros and cons. One big advantage of microservices is the feature velocity, meaning that different teams can work on different microservices, iterate in different speeds, and together with the fact that you can usually use different programming languages, it makes up a polyglot system. Also, you can use different data stores for whatever kind of data you're dealing with. Another advantage of microservice architecture is that you have what we call partial HA or high availability, meaning that it's seldomly the case that your entire application is down. It might be that a certain feature or certain functionality is not available. For example, you might not get a recommendation, but you can still put something in your basket or check out. Now let's talk about the drawbacks of microservices and microservice architecture. It is, as I mentioned, a distributed system. All these different microservices communicate via the network, and with the network there come things like outages, there come delay, etc. It is an increased complexity. You have to think about how to roll out things, deploy, and most importantly in our context, it's about the observability. If you do not pay attention to this topic, to this observability topic, you're effectively flying blind. Remember what we said in the beginning. All right, to make sure that we're all on the same page, let's now do a quick Observability 101. Starting, as usual, with the signal types. First off, we have logs, which are signals with a textual payload that capture events, something like this database has an error condition, or I'm here in this path, and usually are consumed by humans. Moving on to metrics. Metrics are numerical signals, and they are sampled at regular time intervals and usually have their semantics, their meanings encoded either in the name or via labels. You usually do things like you plot them somewhere in a graph like that, or you alert on those metrics. The third signal type that we're talking about usually are traces, or to be more precise, distributed traces. So you have two views there, and both essentially support the definition It's about propagating a certain execution context along a request path of a number of microservices serving that request. So you have things like a service map where you see how all these different microservices communicate with each other. And on the right-hand side, you see the actual traces with the spans there. So you can quickly see in this waterfall model how your request spends the time in what part of the system. All right. The second concept that you need to be familiar with in the context of observability is telemetry. Telemetry is all about getting the signals from where they are produced in your microservices, from the sources as we call them, via agent to so-called destinations. Let's have a look. Typically, if we're talking about cloud-native systems or microservices, there are a number of very popular environments. You can, for example, run something in Lambda, you can run something in Kubernetes, and all of those are producing on every level, be it on the infrastructure level or on the application level, producing signals such as logs, metrics, and traces. In the context of agents, we are moving into a time period where you effectively have a standardization, consolidation of agents. Pretty much everyone out there is moving towards OpenTelemetry. So our AWS distro for OpenTelemetry, or ADOT, is such an example for an agent. And destinations. These are typically something that humans interact directly with. That's what you actually want to be looking at, or you might be storing something like logs, for example, for different compliance reasons. But this is, if it's a front end, something that a human interacts with directly. So sources, agents, and destinations. So that we call telemetry, getting the signals from the sources to the destinations. There is one more thing, and that is the feedback loop. As I mentioned already, usually a human interacts with destinations, specifically with front ends, UIs, for example. However, there is also software that might use these signals in the destinations or from the destinations. The most important thing here is this feedback loop. So why does a human look at the dashboard? What does a piece of software, like think of a cluster autoscaler in Kubernetes, do with these metrics? Well, they change the source. They change the cloud native system, the microservice that emitted that signal in the first place. And with that, we get to a more or less formal definition of observability, and feel free to share that with your colleagues out there. So observability is the capability to continuously generate and discover actionable insights based on the signals from the system under observation, with the goal to influence said system. The key point here is discover and also actionable insights. In contrast to monitoring, where you already know what you're looking at, you know a certain threshold, you know a certain CPU utilization that you want to alert on. In the observability space, you might not know what you're looking for. So I want you to remember that thing. And that is, it's not monitoring is bad and outdated and observability is new. It is that you still need monitoring, but there you already know what you're looking at, what kind of signals, etc., the baseline. Whereas in observability space, you do not know, in most common case, what you're looking for or looking at. So let's have a look at concrete challenges based on what we said so far, what we mean by observability, and what different roles like developers or SRE or DevOps or infrastructure operators may need to do in the context of cloud native services. One issue I already hinted at earlier on is that with the different signal types and different destinations, we are experiencing almost an explosion of different telemetry agents. That has a number of operational downsides. That includes that footprint increases the more agents you add there. You have to patch them, you have to update them, etc., etc. So that's a certain very basic challenge. Another related challenge to that, if you think in terms of the telemetry, is someone needs to instrument the application source code, typically done by developers. And if you have many different agents and many different destinations, you might end up instrumenting it with many, many different SDKs and many different libraries. Remember, the context of our discussion is that of cloud-native systems. So microservices in Kubernetes, microservices using Lambda functions, etc. And they typically have highly dynamic, relatively small units. For example, a pod in Kubernetes might come and go. Lambda functions might be updated, etc. So in contrast to the more static world of a monolith running on a VM, where you had cycles of months, here you might have cycles of minutes or seconds. Once you have certain signals ingested in your destination, the question is always, what is the right retention period? Sometimes this is out of your control. Sometimes you have certain compliance regulations that you need to keep logs for a certain amount of time around. But very often you need to decide what is your retention period. Usually, you're also interested, and that can be a challenge, to minimize either the vendor or feature lock-in. Moving on with buy versus build. Now, buy versus build is not a observability specific challenge per se, but because of the dynamics and because of the newness of the whole ecosystem, you do want to pay attention to it. And I've seen that quite often happening. Where you need to decide, am I going to build a certain integration myself, or am I going to wait until, for example, AWS offers it? We already mentioned monitoring, and one transition there is one challenge, is that people are familiar with monitoring. They know how to go about monitoring. And when you're moving from monitoring to or expanding to observability, it's quite often unclear how to go about what the strategy is to determine what to keep around, etc. The evergreen is everyone wants a single pane of glass for consuming these signals, and the reality is very often when I talk with folks about that, then I get answers like, yeah, over here, that's our single pane of glass, and over there, that's our second single pane of glass, and etc., etc. You get the idea. It is very challenging, but I'm going to show you something that potentially might address that issue for you. One of the most severe challenges, and I'm not aware yet of a open source solution in this space, is what I call signal hoarding. So you essentially collect all the metrics. You're collecting many logs, etc., in the hope of, or because you do not know better at that point in time, that they might be useful at some point in time. So you prune it, if at all, later when you experience a certain billing amount or whatever. So you essentially keep all the signals around, because, referring to number 7, it is hard to move into observability without a clear strategy around that. And last but not least, the correlation of signals, being able to jump from one signal type to another. For example, you might get paged, you have an alert, you start out with a dashboard, and then from the dashboard, you jump to a certain trace, and from that trace, you might jump into logs, for example. So making sure that you can jump between different signal types and synchronize the time ranges there. All right, so those were the challenges. Now let's have a quick look at some open source projects and open specifications that are relevant to our discussion. Starting again with the telemetry part, open telemetry clearly is here to stay and covering more and more signal types as we speak. And this has essentially this idea of having to unify the collector, but also in the instrumentation part. As you can see on the right-hand side, the programming language is listed here, and every day we have a little bit more coverage. So stay tuned and definitely consider already now moving towards OpenTelemetry. The basic unit here in the collector is a pipeline that consists of different parts. There is a receiver where you're working with the sources. Then you have a processor where you can do some intermediate processing, for example, batching. And then you have an exporter that communicates with the destination, being able to ingest data into a specific destination. What is shown here is the default configuration of our ADOT collector at this point in time. All right, so I thought one way to go about the different open source projects, because there are many different ways, is slicing them along the different signal types. So let's start off with logs. Two rather interesting and popular choices there. OpenSearch, probably not a big surprise. You might have already heard or maybe been using it. This idea of essentially full text indexing, and then you can essentially look up your log lines there. Loki has a slightly different approach there, in the sense of that Loki essentially only indexes the tags, and you're essentially looking up stuff or the log lines via the tags. Both of them are, as I said, popular, and depending on your use case and your preferences, you might want to have a look at the one or the other. In the metric space, the most prominent one, Prometheus and the Prometheus ecosystem, that includes the long-term storage and federation projects called Cortex and Thanos. And Prometheus is essentially, if you think about it, a time series database that is able to enables you to query those metrics and can, through various protocols, remote read and remote write, ingest the data into things like Cortex and Thanos. Last but not least, in the traces space, we have two open source projects that are mainly concerned with distributed traces. That is Jaeger and Zipkin. And in the context of a single machine, if you are looking at profiles and what the execution in a single machine is, you also might want to check out Parka, which is eBPF based and does the tracing for a single machine in the same way that Jaeger and Zipkin does that for multiple machines or multiple services. Moving on to what I hinted at earlier already, the single pane of glass, Grafana. In this case, you see three different panels that use data from different data sources. The first panel uses log data from CloudWatch, the second one metrics data from Prometheus, and the third one, the bottom one, uses traces from X-Ray. And there you can already see this correlation of the different signal types. So, for example, due to the uniform interface that Grafana allows you to use, you don't need to know the different query languages like PromQL, for example, for Prometheus, to be able to select a certain time range or to filter for a certain attribute or for a certain tag. And all these different panels are synchronized, meaning that if you zoom in one place, for example, the metrics, all the others, the logs and the traces, are also selected in this time frame. Same applies for filters and so on. So Grafana, long story short, potentially being this single pane of glass for you. One word on open specifications or de facto standards. The OpenTelemetry project, as I mentioned, is there, and this is there to stay. It came out of a merger of two other CNCF projects called OpenSensus and OpenTracing. In OpenTelemetry, we currently have the traces. They're already GA, meaning they are stable. You can use them in production. In terms of the metrics signal type, we are still working on that. So the different stakeholders there, the Prometheus community and the OpenTelemetry community, working together in a working group to make sure that the metrics are also stable as soon as possible, and the logs are still work in progress. Specifically regarding metrics, There is the open metrics format, which is an aspiring IETF draft that is derived from the Prometheus exposition format. So you want to probably, when you're instrumenting that, you want to use metrics there, and through the interoperability, you can use the OpenTelemetry collector, the ADA collector, for example, to scrape your Prometheus endpoints and to ingest that based on open metrics. So now the question, how can open source help with those challenges? Before we get into a concrete mapping, a few high-level good practices. You want to find and then use the best of class tool for a given use case and role. Use case that might be depending on your environment, that might be depending on your frequency, how you deploy, etc. And role takes into account the different roles like developers, infrastructure, ops, etc. Have different flows that they need. So you might end up with different tools, but they're best of class for that specific use case and role. You do want to rely on open standards such as OpenTelemetry and OpenMetrics as widely as possible. Now, there are still challenges at the time of the recording in terms of OpenTelemetry not being fully stabilized across all signal types, but that doesn't mean that you can't already go ahead and start using OpenTelemetry for traces, and as we move forward for metrics. You do want to build portable observability systems. One part of it are these open standards and open source tools. Think of it, for example, if you're moving from an on-premises environment into the cloud, and you can essentially reuse all your entire setup. You don't need to re-instrument. You can use the same agents. You can use the same destinations, etc. So you really want to keep that in mind to build portable systems there. One of the most challenging things in terms of deciding what to build and what to do is that you very often upfront not know what will have a certain impact or a certain return on an investment. But you do want to essentially have it return on investment driven. So ask yourselves, or can probably assess what are the costs for a certain work item, for example, instrumenting something or running an agent or whatever. And then you want to compare that with what you get out of that. Can you, because of a new signal type like tracing, for example, in a microservices setup, can you iterate faster? Can you be more reliable? Can you ship more features? So keep that in mind that you do want to make return on investment driven decisions here. So how do these different challenges that we went through map to the open source tooling and specifications we discussed? Well, the agent overhead, so having to run multiple agents, is more or less trivially going forward resolved more or less through using OpenTelemetry, the OpenTelemetry collector. The same is also true for instrumentation. So if you're using OpenTelemetry, it's relatively easy to move from one destination to the other. And as I said, for metrics, you want to use OpenMetrics as a format to emit OpenMetrics. For logs from cloud native system, remember those are systems that are highly dynamic and changing their services quickly. You have open source projects like Loki or OpenSearch. For metrics, Prometheus, and for long-term storage and federation, Cortex and Thanos. For traces, you have, again, OpenTelemetry. You can already use there because it's stable in this for this signal type. There are things like Jaeger and Zipkin, but also Grafana for the consumption as a destination front-end example. For the signal hoarding, as I mentioned already earlier on, I'm not aware of a open source project that would essentially address that out of the box. So you essentially have to prune on ingest as much as possible. And for the single pane of glass, as I said, and for the correlation of signals, my recommendation would be Grafana. And with that, we have essentially at least a rough guidance on that. I wanted to call out that build versus buy again. If you look at what we provide here, there are, of course, the AWS native services like CloudWatch and X-Ray. And then there are a number of open source based solutions. And for some of them, like Grafana and Prometheus, we also offer managed services. So imagine you're in a situation where you need to decide on a strategy, your observability strategy. Then make sure that you really only own and build what you need to build, and try to outsource as much of the heavy lifting as possible to your cloud provider of choice. All right. And with that, I thank you very much for joining me in our session.